Hey everyone, I'm Anthony Cronander. I'm a senior analytics engineer here at Drata, and today we're excited to share how we're scaling data-driven decision making at Drata and moving from sort of traditional internal analytics to AI-powered customer success using Cube's semantic layer and AI agent D3. Before we dive in, just to set some context, here at Drata, we're the leading AI native trust management platform, now helping thousands of businesses develop a more secure, proactive, audit-ready, and risk-aware organization to continuously maintain trust. And as we've grown, we faced a critical challenge that many of you might be able to relate to, and that's how do we scale our analytics capabilities without scaling our team linearly? So here's what we'll cover today. First, I'll introduce Drata and explain why Cube matters to our analytics engineering practice. And then I'll walk through the core challenge that we're solving, scaling those analytics with the finite resources that we have. After that, we'll dive into our dual approach to Cube, how we're using one semantic layer to power two completely different consumption patterns. Then I'll cover the technical architecture that makes this possible. And we'll go through our two main use cases, the multi-instance management dashboard and the QBR automation workflow that we're piloting currently with D3. We'll share our lessons learned along the way, particularly around building trust in AI-generated insights and designing semantic layers that work for both humans and AI. Finally, then, we'll wrap up with some key takeaways. Let's get started. So who we are. Drata is the leading AI native trust management platform, and we automate and centralize governance, risk, compliance, and assurance for thousands of businesses across the globe, including a third of the Cloud 100. Our mission is to build trust across the cloud and serve as the trust layer between great companies. Now, as our data platform team matures and our customer base grows, we need to deliver real-time insights both internally to our own teams and externally to our customers and partners. The traditional approach would be to scale our data team proportionally with demand, but as you know, that's not realistic or sustainable. That's where Cube comes in. So Cube's semantic layer gives us a consistent, governed foundation for analytics that scales with us. So we can define metrics once, secure them, and then consume them in multiple ways. So through APIs, AI agents, direct queries, all without rebuilding the logic every time. This becomes our single source of truth and empowers everything from customer-facing dashboards to AI quarterly business reviews, like you'll see later. So on the left, you'll see some details here about the problems that we face. So our customer base is growing rapidly, and they're demanding access to real-time insights. Our customer success teams need to create data-driven QBR presentations for every major account. And this can take several hours per account for each of the accounts that a CSM manages. So this often results in dozens of hours every quarter. We also have clients who manage 20 or more accounts that need a unified dashboard to see everything across the different accounts at one time. Meanwhile, our data team and our CSM resources are limited and valuable, so we cannot just throw more headcount at this. On the right, you'll see some points about where our traditional approaches fall short. So building custom dashboards for every use case does not scale. Manual reporting generation takes CSMs dozens of hours per quarter. They're pulling metrics from 5 different dashboards, calculating benchmarks by hand, formatting things into slide, and sort of building the narrative that they want to tell piece by piece. So when these data sources are disconnected, you can end up with inconsistent metrics, and this can erode trust with our clients. So as we grow, this and our security and access control all become increasingly complex. So how are we solving this? We're using what we call a dual approach to Cube. We have two distinct consumption patterns built on one semantic layer. On the left, we have structured API queries. So this is what powers our multi-instance management dashboard. We're using predefined queries through the Cube REST API to support in-app reporting with multi-tenant row-level filtering. This is closer to that traditional approach. So we know exactly what metrics we want to surface, but we can build them in Cube and expose them via the API to our front-end application. This way, we can get scalability and security of the semantic layer, as well as benefits of things like caching that you get with Cube. On the right, we have AI-powered integration. So this is where things really open up. We're using Cube's D3 AI agent to process natural language queries on top of the same semantic layer that provides specific context and governance around QBR related metrics in this case. So instead of using predefined queries, we're relying on this layer. CSMs can ask questions naturally, and D3 can intelligently query the data, compare benchmarks, and generate insights. Here's why this works. We're focusing on specific metrics for specific use cases. We maintain a single source of truth for metric definitions across the organization. We have a consistent security model across the different use cases. We build semantic models once and consume them in many ways. And critically, AI works with reliable, governed data, not raw tables that could potentially have data quality issues. So I'll briefly show how this all fits together in our data stack. We have three main layers. At the foundation, we have Snowflake as our data warehouse. This is where data sources from every area of the business and application all come together. We use dbt then to create clean, tested data marts, and we have decodable, streaming, near real-time updates for a lot of our key metrics. This is also where we can enforce row-level security through user mapping. In the middle, we have Cube as our semantic layer and AI analytics engine. Normalized cubes define our core business entities, things like accounts, frameworks, controls, etc. Views combine those cubes for specific use cases like the QBR metrics or the multiple instance management dashboard. Security contexts there are applied via the query rewrite functions for row-level access control, and we have specially instructed Cube AI agents that are designed to tackle specific challenges, like the QBR generation. The consumption layer, we have multiple patterns. Like mentioned before, the REST API powers our in-app dashboarding, like the multiple instance management dashboard. The Cube AI agent, D3, handles natural language queries for QBR automation. And we still support direct SQL queries for internal analytics when the data team needs to dig deep. Now let's dive into our first use case, the multi-instance management dashboard. This dashboard is for our managed security service providers who need to manage multiple client accounts at one time. They often have 10 to 20 different accounts, and logging in and out of each of those accounts to look at metrics can be exhausting and time-consuming. So let's walk through the business need, some key metrics in our solution. First, the business need. So these clients manage anywhere from 10 to 20 Drata client accounts. Previously, they needed to log into each account individually, check things like compliance status, framework readiness, and control testing metrics. It was incredibly time-consuming. They needed a unified view across all clients without logging in and out repeatedly. They also require near real-time compliance metrics and health indicators on these accounts. And critically, we have to maintain strict data isolation per client. Second, the key metrics that we're surfacing. Things like framework readiness across all the clients. Are they ready for SOC 2? Things like that. Control testing metrics and automation. Asset monitoring for security posture. Vendor risk assessment. Policy compliance, and more. Our solution. We use structured API queries against our predefined semantic layer in Cube to support an in-app dashboard. In partnership with our engineering team, we utilize account-based access mapping to determine which accounts an MSSP user can see. We do regional data filtering to ensure compliance with data residency requirements. We validate account status through the Cube API query to make sure that we're only showing active accounts. And we have in-app validation measures on delivery as well to catch any edge cases. This all ensures that we control the data flow each step of the way and provide a consistent in-app dashboarding experience for all of our users. Now, let's talk about our second use case, which is where AI really comes into play for the automated quarterly business review generation, or QBR for short. This slide breaks down the transformation that we're accomplishing here. On the left, the manual process. CSMs are spending 2 to 3 hours per QBR. When you multiply that across multiple QBRs per CSM per quarter, you're looking at 20 to 30 hours per quarter per CSM. That's almost a full work week every quarter just building presentations. They have to manually pull metrics from 5 different dashboards, calculate benchmarks and percentiles by hand, and compare their customer to similar customers in the segment. They were formatting data into slides, copy pasting, and they were crafting strategic recommendations based on the information that they saw. This is both time consuming and it doesn't scale. That's where our AI powered pilot process comes in. The CSM can provide account context and focus areas. Maybe they'd like to focus on automation opportunities, for example, or they have a lower headcount than they did the previous year. D3, our AI agent, can query the semantic layer intelligently and select the most impactful metrics for the specific account and focus area that was defined. It can generate data-driven narratives, not just numbers, and insights written in natural language that the CSM can use. It surfaces retention risks, expansion opportunities, and compares metrics to benchmarks, all while identifying outliers. It outputs presentation-ready insights as a JSON that we can take and programmatically turn into slides. With our AI-powered approach, CSMs get dozens of hours back in a quarter and are given everything they need to support intelligent storytelling crafted through our semantic layer and D3. This is a shift from static reporting to intelligent storytelling that I had mentioned before. So let's go under the hood now and look at our semantic layer. So starting on the left, just to kind of break down, our semantic layer includes 10 different dedicated cubes for various entities of the QBR data. Things like framework readiness, compliance status, control automation, vendor assessment, security posture, things like that are all broken out into individual cubes. On the right are some of our design principles for AI. Clear, descriptive, dimension, and measure names are vital. Everyone at the organization should be able to understand the data just by reading the name. Rich metadata and documentation should be as comprehensive as possible. The more context around the data and its use cases, the better. Every measure should have a description explaining what it means and how it's calculated. Pre-calculate more advanced metrics and define clearly. For us, this means pre-calculating benchmarks against different segments, industries, and other cuts of the data. We don't want D3 calculating percentiles on the fly every single time if it doesn't need to, and that data doesn't need to be real time. Relationships are clearly defined between entities. Frameworks contain controls, accounts have frameworks, etc. And consistent metric definitions across all cubes to ensure that when a metric is defined, it means the same thing everywhere it's used. And this is really critical. So AI is only as good as the semantic layer that it's querying. If your cube definitions are unclear, your relationships are not explicit, or if your documentation is sparse, the AI will struggle to generate accurate insights and may make incorrect assumptions about your data. Let's walk through the QBR automation workflow. Step 1, CSM input. This happens via a Snowflake Streamlit app that I've created or within the D3 UI directly. So here we can use the account name or ID handled by Snowflake or through Cube through the user attributes. And then the CSM can provide additional context. So this is things like the customer is preparing for an ISO audit. Maybe they want to focus on automation opportunities, or they mentioned something like a lack of headcount this quarter. Step 2, D3 agent analysis. And this is where the magic happens. D3 interprets the natural language request and queries the semantic layer for all the relevant metrics. It compares performance to segment benchmarks. It defines trends, anomalies, and opportunities. It generates strategic recommendations with narrative context. And it highlights retention risks and expansion opportunities by looking at things like engagement, compliance gaps, and commercial data. It enables conversation-based iteration between the CSM and the agent so they can ask follow-up questions and refine the analysis as they like. This is really powerful as the agent becomes a storytelling partner rather just a dashboard servicing metrics. Number 3, presentation generation. D3 outputs structured JSON with all the insights and metrics. We've provided additional instruction and context to the agent here to ensure the output matches our desired format. We apply things like consistent Drata branding, we create visuals, and we ultimately generate JSON for a presentation-ready slide deck. From here, our internal script can translate the JSON to Google Slides, and the CSM can add some polish, finishing touches, review it, and start to distribute with their clients. So one of the most powerful features here of the QBR automation is our context injection, as mentioned in the previous slide. So on the left, These are some examples of some of that context that the CSMs could provide. So things like the customer mentioned concerns about vendor risk during the last call, or they're preparing for an ISO 27001 audit in Q2. This is all gold for our AI agent. When a CSM provides this context, the agent doesn't just run a generic analysis. It will prioritize the relevant metrics based on that context. So if the customer mentioned vendor risk concerns, for example, D3 will surface vendor management metrics prominently and look for trends or gaps. This creates a more personalized, actionable narrative that will cater to each and every account and will help CSMs identify specific expansion opportunities that are aligned with customer needs. The result here is that QBRs feel tailored, not templated. Customers' actual concerns are addressed, and our CSMs can demonstrate deep knowledge of each account. This builds trust and helps to guide our relationship with each customer to a strategic partnership. So here's what this looks like in practice. This is an example of the Snowflake Streamlit app interface for the Cube D3 QBR automation bot. At the top, you'll see that the employee email is shown, and then an account was selected from a drop-down menu. Below that, there's a text area for additional context. When the user clicks Generate QBR, D3 processes that context and provides a comprehensive response. On the right, you'll see the AI response showing key insights structured in a narrative format. So strengths to celebrate, critical gaps, areas of excellence, things like that, all crafted together in a narrative that the CSM can take and apply when they share this with the client. Below that, you'll see some JSON output, the structured data that we'll use to programmatically generate slides. This is our alternative interface using Cube's native D3 UI. You can see here that the CSM types a natural language prompt. From here, you can see the agent searching through the semantic model, reading our rich context, and identifying relevant metrics around automation, evidence percentage, frameworks, etc. On the right there, you can see a snippet of the structured JSON output. With this output, you can also see the reasoning trace, showing how the agent is thinking, which parts of the model it was searching, which queries it ran, and how it's building the narrative. This sort of transparency is important for building trust in AI-generated content. Where this interface shines is in the conversational experience that it offers between a CSM and AI agent, allowing for faster iteration. As we think about rolling this out across our organization, we're taking a deliberate, phased approach to build trust and refine the product. Phase 1 is our internal pilot, which is where we are currently. So we have a small group of power users testing the workflow across 5 to 10 clients. These are CSMs comfortable with AI agents that are willing to give us detailed feedback. Critically, the AI output is programmatically checked against database queries to ensure data quality. We're using this phase to build trust. We gather feedback on the narrative quality and relevance, the metrics, whether or not the language feels natural, the identification of trends, and more. Phase 2 is an expanded beta. We'll roll this out to 10 to 15 CSMs across different segments, between mid-market, enterprise, and different industries. We'll expand the template library for common QBR scenarios. We'll establish best practices for context injection for the CSMs to use. And we'll continue refining and enhancing the semantic models based on feedback. Phase 3 is full CSM adoption. Here's where we'll deploy this to the entire organization. We'll have an automated QBR scheduling and generation feature, and we'll provide enhanced self-service analytics for internal teams. Eventually, we'd like to integrate this into the Drata application for customer self-service. Now onto some of the lessons that we learned through this process. One of the biggest challenges with AI-powered analytics is trust. CSMs need to trust that the numbers are accurate, the insights are relevant, and that the recommendations are sound. And here's how we're building that trust. First, we pressure test D3 output with internal stakeholders before rolling it out to CSMs. Second, we use Snowflake notebooks and other evaluation tools to regularly validate metrics against benchmarks. On the right side of the slide here, you'll see an example of this. Third, we iterate on semantic models based on feedback. Fourth, we regularly enhance context, documentation, instructions, descriptions, all to guide D3 to better responses. Fifth, we establish feedback loops with pilot CSMs. After every QBR, we can ask, were the insights accurate? The recommendations helpful? What would you change? The key here is that our AI agent is only as reliable as the semantic layer it queries. This upfront investment pays dividends in the accuracy of the agent and builds trust incrementally. If you want reliable AI insights, you need a rock-solid semantic foundation. And in building that foundational semantic layer, we learned how designing for AI is different than designing for humans. For example, for humans, intuitive navigation is important. You want best practice repository organization, sensible naming conventions, and good documentation. Familiar business terms matter, so remaining consistent with business terminology. The semantic layer should feel like an extension of the business, not a new data entity that people will have to learn. On the right, building for AI. Description names are vital. Avoid abbreviations and acronyms without explanations. Call things what they are. Metadata and documentation should be as rich as possible. Relationships must be explicit. Metrics should be very clearly defined. Through this, we ultimately learned to design the semantic layer for AI first, and humans will naturally benefit. If your semantic layer can successfully guide an AI agent to the right answer, it's most likely readable for human analysts as well. I'll wrap up here with some of the additional key takeaways. First, build once, consume many ways. Use a semantic layer as your source of truth. You can support many types of data consumption from this: APIs, AI agents, direct SQL, embedded analytics, etc., all from the same foundation. Second, start simple and iterate quickly. D3 makes it easy to begin with a focused semantic model and then iterate with more data. Build what you need for a specific use case, validate it, and expand based on your actual needs, not hypothetical ones. Third, an AI-focused semantic layer design will yield good documentation and clear definitions. Invest in that clarity early, and AI will become a force multiplier. If your data modeling is messy, an AI agent won't function the way you expect. Fourth, trust requires validation. Build confidence in AI-generated insights through rigorous testing, evaluations, and an explicit semantic layer. Trust is earned incrementally, not given automatically. Thank you. That's our story, and we're excited where we're headed with Cube and the D3 AI agent, and wanted to thank everyone for your time today. You can reach us here with our emails on screen, and if you're interested in learning more about what we do at Drata, visit the link below. Thank you.